Hello everyone. Assalamu alaikum. I am Salman Ibn Yunus. In this presentation, I will introduce to the topic or the problem which the paper has attempted to solve using deep learning techniques. So as you can see in the image on the left, so the first image shows the normal retina and the second image shows the retina of a diabetic retinopathy patient. As you can see that the diabetic retinopathy patient have abnormal growth of blood vessels and also hemorrhages and spots. So there are approximately 600 million people who will have diabetes by the year 2040, and among them one third is expected to have diabetic retinopathy. So diabetic retinopathy is the most prominent cause of vision loss in working age adults worldwide. As a result, regular DR screening, that is diabetic retinopathy screening, is recommended as it will ensure early detection and thus the treatment can be done at an earliest time possible to reduce or prevent the vision loss problem. The common scenario is that comprehensive DR screening is not carried out widely due to lack of human assessors and also due to lack of trained individuals. As a result, a diagnostic system, an automatic diagnostic system is needed, which can be done using deep learning algorithms to facilitate DR screening. Introduce so in this paper, they have actually captured retinal photographs using desktop retinal cameras, and operators were all trained and they all followed standard procedures. So the images were further also verified using 33 certified ophthalmologists. For each type of lesson, two ophthalmologists produce two lesson annotations. So as you can see in the figure, that local set was randomly divided into training and validation sets. So the 6,247 images in the training data sets were used for training the image quality assessment subnetwork. So the diabetic retinopathy severity was graded into five levels, which includes non-diabetic retinopathy patients, mild non-proliferative diabetic retinopathy patients, moderated non-proliferative diabetic retinopathy, severe non-proliferative diabetic retinopathy, or proliferative diabetic retinopathy. So the images has been divided like this, like low quality images and high quality images are divided according. So in this, so if you take a look at the architecture of the model, so a deep learning based DR screening system has been devised by the authors of the paper, which they called as deep learning diabetic retinopathy or deep DR. So these consist of three deep learning subnetworks. One is called image quality assessment subnetwork, lesion aware subnetwork, and DR grading subnetwork. So as you can see, initially they checks the image quality, then they checks the lesion lesions, and then finally they checks the DR grades. So these subnetworks were developed based on ResNet and Mask RCNN. So it's a transfer learning based multi-task network to evaluate retinal image quality, retinal lesions, and DR grids. Both ResNet and mask are seen and could be divided into two parts. Number one is a feature extractor, which took images as input and output features. Secondly, the task specific header, which took the features as input and generated task specific outputs, that is, classification or segmentation. Then, if we take a look at the results and performance, they are outstanding. So, the area under the curve results, as you can see in the diagram. So DeepDR achieved an AUC of 0.9344 for overall image quality. For the identification of artifacts, clarity, and field definition issues, the system achieved AUCs of 0.93. So all the area under the curve scores are above zero point 0.9. So for micro aneurysm, as you can see that the sensitivity, specificity, and F score were above 0.99 mostly. Somewhere 80, the specificity were in some cases were 88%, and the F score was 0.815. For CWC, the AUC sensitivity, specificity, and IOU were 0.941, and for hard exhibit, the AUC sensitivity and specificity and IOU, that is intersection over union, were 0.954, 90.5%, and 85.8% respectively. For hemorrhage, the AUC sensitivity, specificity, and IOU were 0.967, 93.2%, 88%, and 0.738 respectively. So to conclude, we can see that the deep DR system has achieved high sensitivity and specificity in DR grading. So rather than just generating a DR grading, it offers visual hints that helps users to identify the presence and location of different lesion types. So as you have seen that they have introduced the image quality subnetwork and lesion aware subnetwork into deep DR, which has improved the diagnostic performance and more closely followed the thought process of ophthalmologist. So the ophthalmologist thinks in a specific way, and when human assessors, trained human assessors, use those, actually try to diagnose those diabetic retinopathy patients. So they follow up thought process, and the similar thought process was also followed by the deep DR system. So to conclude, we can say that deep DR can run on a standard personal computer with average performance processors. That thus it has great potential to improve the accessibility and efficiency of DR screening. That's all from my presentation today. Thank you all for listening and having patience. See you all later. Thank you.